Hello everyone, welcome to your physics class of class 8th. I hope you all will be fine. Students, in our previous video we had started lesson number 7. Now today in this video we will continue that lesson. Okay, so let's begin our class. Lesson number 7, sound. In our previous video we discussed about sound, then propagation of sound in air, terms related to wave, that is amplitude, time period and frequency, and relationship between time period and frequency. And also wavelength, we discussed about wavelength, and also representation of a wave, that is displacement distance graph and displacement time graph. Now today in this video we will discuss about characteristics of sound. A sound wave is characterized by its amplitude and frequency. Means we can characterize a sound wave on the basis of its amplitude and frequency. Now, depending upon the amplitude and frequency of a sound wave, the two sound waves can be distinguished from one another by the following three different characteristics. And what are those characteristics? First one is loudness, second pitch, and quality. Now, first one is loudness. Now, we will discuss them one by one. First one is loudness. Loudness is the characteristic of sound by virtue of which a loud sound can be distinguished from a faint sound, both having the same frequency and same waveform. Means if two sound have the same frequency and the same waveform, we can distinguish them by the characteristic loudness. So loudness is that characteristic of sound by virtue of which we can differentiate between two sound waves, means whether it is loud sound or faint sound, both having the same frequency and same waveform. Even though they are both the sounds are having the same frequency and same waveform, we can distinguish them by loudness, whether it is a loud sound or a faint sound. Loudness of a sound depends on the amplitude of vibration of a vibrating body producing a sound. Means the amplitude, means the distance, the maximum distance that a body through which a body vibrates on their mean position, from their mean position, the maximum distance, that is known as amplitude. Okay. So by amplitude, the loudness of sound depends on the amplitude of vibration, means the maximum displacement through which a particle vibrates on their mean position. Okay, so that is known as amplitude. So so loudness of the particle of the sound depends on the amplitude of vibration of the vibrating body producing sound, means the body that is producing sound. Now greater the amplitude of vibration, means the greater distance, the displacement of the particle on either side of its mean position, that is known as amplitude. So greater the amplitude of vibration, louder is sound produced. Okay, as you can see here, two waveforms A and B. Now they both have the same frequency and same waveform. Okay, both these have the same frequency and same waveform, but the amplitude, the distance, maximum displacement of the particle from its mean position varies. Here it is 2 meter and here it is 4 meter. So here the amplitude is large as compared to waveform A. Therefore, the sound produced by this wave is greater. The amplitude of wave B is greater than A. Hence the sound B is louder and then is louder than sound A. Okay, because the amplitude of sound B is larger than the amplitude of sound A. Okay, so therefore sound B is louder than sound A. For example, if you gently pluck the string of sitar or guitar, a soft sound is heard. But if you pluck the string hard, it gets displaced more from its rest position, means the amplitude is more. That is, its amplitude of vibration increases and so a loud sound is heard. Same way, if you strike the drum gently, a faint sound is heard, but if you strike the drum hard, you hear a loud sound because the amplitude is large when you strike it hard. Okay. Now third is, if you gently strike a turning fork on a rubber pad, you will hear a feeble sound, or we can say soft sound. But if you strike it hard on rubber pad, a loud sound is heard. Similarly, if the key of a piano is hit harder or a pipe is blown harder, we put more energy in the vibrating system, due to which the amplitude of vibration is increased, means the displacement of the particle that is vibrating is maximum, is more. Therefore, the amplitude of the vibration is increased and a loud sound is produced. Now, factors affecting the loudness of sound. The loudness of sound depends upon the following factors. First one is on the amplitude of wave. When a body vibrates with greater amplitude, it sends forth a greater amount of energy, and hence the energy received by the eardrum is large. So the sound heard is louder, means when a body vibrates with a greater amplitude, it sends further the greater amount of energy to the nearby particles, and when it reaches our eardrum, it is the energy received by our eardrum is large, so the sound heard is louder. As we have seen from in the example, when we beat the drum harder, it produces greater amplitude, and because of that greater amplitude, we hear the loud sound of the drum. Now, second one is on the distance of source of sound. If the listener is close to the source of sound, he hears it quite louder, but if he is far away, the sound becomes feeble. If he moves further away from the source, a stage may reach when the sound becomes inaudible. Thus, closer is the source, the louder is the sound heard. Means if we are closer to the source of sound, we hear it quite louder. But if we are far away from the source of sound, we hear a feeble sound. Now, third factor is on the surface area of the vibrating body. When the vibrating area is large, greater amount of energy is produced, and the amplitude of the vibration is large, and hence the larger the surface area of the vibrating body, loud sound is heard. As we can see here, if we take two drums, one small and the other big, and if we beat them, both produces vibrations, but the vibrations produced by the big drum is vibrations produced by the big drum has a greater amplitude as compared to the small one. Therefore, the sound produced by the big drum is louder as compared to the small drum. Same way, in temples, you must have noticed that the bell with a big case produces louder sound than with its small case. Okay. Now, fourth factor is on the sensitivity of the listener. The loudness of sound depends on the sensitivity of the ears of the listener. A given sound may appear to be loud to a listener and not so loud for the other listener. To a partially deaf listener, a louder sound will appear to be feeble. Okay. Now, relationship between loudness and amplitude of wave. The loudness of sound is directly proportional to the square of the amplitude. It means that on doubling the amplitude of wave, the loudness becomes 4 times. Means loudness is directly proportional to the square of loudness. L is directly proportional to the square of amplitude. So, if the loudness is doubled, if the amplitude is doubled, the loudness becomes 4 times. Okay. Now, unit of loudness. Unit of loudness is decibel. Okay. Now, here in this table, you can see the level of sound in decibel produced by these different objects. Okay, so you can read this table. Now, the safe limit of level of sound for hearing is from 0 to 80 decibel. The sound level 10 decibel to 30 decibel has soothing sensation. A constant hearing of sound level above 120 decibel can cause headache, permanent damage to the ears of the listener, and such sound is called noise. Okay, so this is all for today. This characteristic we studied about loudness. What you have to do in homework, you have to read this lesson up to here, so it will be more clear to you, and further explanation I will give you in the next video. Okay, thank you.